We're going to take a quick break from probability to develop counting techniques, and we will be using these counting techniques to do some more involved probability. That's what we'll call them, more involved probability problems. So what we're looking for is how many ways can something happen. So we're going to look at the basic counting rule, and then permutations and combinations, and when to use what. So to illustrate this particular principle, let's continue. Suppose you're at a restaurant and order a skillet cookie for dessert. You have your choice of 3 types of cookies: chocolate chip, peanut butter, and a sugar cookie, with a scoop of either chocolate or vanilla ice cream, and topped with one of the 3 toppings: hot fudge, caramel, or strawberry. If you're allowed to choose exactly one item from each category, how many different skillet cookie options are available? Well, basically, again, we are just asked how many. That's all they're interested in. So we have some methods that we could utilize. And I think that you have seen some of these methods before. You could write out all the options, make a tree diagram of your options. I think some of you may have seen this tree diagram before. Or we could use the basic counting rule, and that's what we're going to focus on. Now I'm going to pause the video just for a little bit, and I'm going to write out a tree diagram and then write out all the options. Maybe we'll appreciate method 3 using the basic counting rule just a bit. Okay, as you see, most people would use method 2 to make a tree diagram to actually write out all of the options. But we see here that we have, let's see, 1, 2, 3, 4, 5, 6, 18 possible options, possible combinations of all these items for our skillet cookie dessert. Well, that was pretty tedious, and if you weren't interested in specifically what all those options were, we could have just used the counting rule. And with the counting rule, we had 3 types of cookies. We had 2 types of ice cream, and we had 3 types of toppings. And we could just multiply those together, and we would have 18 ways that you could have a skillet cookie dessert. So let's generalize that. If we are asked to choose, I see another thing that needs to be changed from in your notes. One item from each of K categories, where there are n sub 1 choices for the first category, and that would be in our case 3, n sub 2 choices for the second category, and that would be R2 in this case, and so on. Then the total number of available choices is, so we have our n sub 1 times n sub 2, and then times, and then we're going to just assume we don't know exactly how many. Let's say we have the K choices, as they mentioned, K categories, I should say. What we're going to do is just multiply all those choices in each category together. And that's it for the basic counting rule. So let's look at example 18. Suppose you are grocery shopping and want to buy granola bars. You have 6 choices of flavors, 3 different brands, and 2 sizes of boxes from which to pick. If you want to buy 1 box of granola bars, how many different options do you have? Well, we have 6 choices of flavors, 3 different brands, and 2 sizes. So we would have 36 ways I guess in this case, let's go ahead and use options, right? 36 options of how we would want to buy our granola bar. Okay, B, you are taking a quiz that has 4 true-false questions and 4 multiple choice questions, each with 3 possible answers. So true-false, there are only 2 choices, right? Except for those of you people who try to write this, it always cracks me up. Sorry, that's going to be wrong for me, just so you know. And 4 multiple choice questions, each with 3 possible answers. So the multiple choice have three options. So how many ways can you answer the quiz? So we have 8 questions. Okay, and you only have 2 ways that you could answer those true, false. And then you only have 3 ways you could answer the multiple choice. Okay? And just because you answered true on question number 1 doesn't mean you can't answer true for, well, all of them, right? Regardless of what you put on question number 1, that's not going to affect what you could put on question number 2. Now, some of you know that you can write this shorthand by using exponential notation, and I get 1,296 ways that you can answer that quiz. All right, at a small high school, there are 86 students. 20 are freshmen, 30 are sophomores, and 15 are juniors. They didn't tell us how many seniors there are, but I'm pretty sure that we all know how to subtract. See, we have 20 freshmen, 30 sophomores, 15 juniors. Having trouble writing here. So we want to know how many seniors we have. So I'm just going to subtract the 86 minus 20 minus 30 minus 15, and we should get 21 seniors. Now that wasn't so hard, was it? So if the school needs 1 representative from each class, how many different possible ways are there to randomly select representative from each class? So no popularity contest here, they're just randomly choosing a representative. So 20 times 30 times 15 times 21, and there are 189,000 different ways that could happen. All right, lastly, you're required to choose a password beginning with 3 lowercase letters and ending with 3 digits. Okay, please remember that digits are 0 through 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's 10 choices. And it says repetition is allowed. How many different passwords are possible? Okay, well, you have 26 choices for the first one, 26 for the second one, 26 for the third character there. Okay, and then for the numbers, we have 10 choices for the first one, 10 choices for the second one, and 10 choices for the third. So let's multiply that out. And we get 17,576,000 different passwords are possible.